Welcome to video 7.1, One Sample Significance Tests. For our scenario today, we have Chicago-style popcorn as a type of popcorn made by mixing together cheddar and caramel popcorn. True Chicago-style popcorn is composed of at least 40% caramel corn. A new popcorn shop advertises that they will be selling Chicago-style popcorn. To test this claim, a popcorn lover takes a random sample of 500 kernels of the popcorn and finds that 183 kernels are caramel. Do the data provide convincing evidence that the shop is not selling true Chicago-style popcorn? So before we even begin, the last sentence, do the data provide convincing evidence that the shop is not selling true Chicago-style popcorn? That is an indication that you're going to perform a significance test. So we have our first AP tip today. If you see the words, do the data provide convincing evidence, that means you're doing a significance test. And in a review of the recent FRQs on recent exams, all had at least one, and some of them even had more than one significance test as part of their FRQ. So we want to be sure that we have a good understanding of what we're doing here and that we're answering the right question the correct way. All right, so let's go back and look at our scenario. So we've got some important information here. First thing, as we start reading, I see this 40%. The 40% says we're talking about a proportion. If I wasn't sure as I continue to read through this, I do not see the words mean or standard deviation mentioned at all in the problem. That gives me further evidence that this is a proportion problem. They say they take a random sample. That helps us know that this is one sample. And then the person goes on to say they found 183 out of 500 kernels were caramel. It's a p-hat. So we had a p-hat of 183 out of 500, which gives us, when you do the division, you get 0.366. That's all the calculator says. You need to use all three of those digits when you're doing your work through here. All right, so for our state portion, we need to define our parameters, write our hypotheses, and include our alpha level. So for our parameter, we know this is a proportion, so we have to use the notation of P. And unlike a confidence interval, it's not exactly stated how we need to define here, but it's pretty close. Do the data provide convincing evidence that the shop is not selling true Chicago-style popcorn? So really, we're wanting to know about the true proportion of popcorn in the Chicago-style popcorn at this store, because they're talking about this new store. So we have the true proportion of caramel popcorn in the Chicago-style at this store. Now we need to write some hypotheses. So if it's going to be considered Chicago-style popcorn, it must have at least 40% caramel popcorn. So for our null, we're going to say the true proportion is that 40%. Okay, so remember when we're writing hypotheses that your null has an equal sign. Now for our alternative, we have some choices. So for our alternatives, we can have either a greater than, a less than, or a not equal to. So we need to look at our problem and figure out which one. So if it has more than 40%, that's fine. So we're not worried about the more than sign. What's really concerning is our sample had less than 40%. Okay, so our alternative here is that the true proportion, this is what we think is going on based off our sample, is less than 40%. And we want to include our alpha. It is not stated here for us. If they don't tell you, generally you're going to use 0.05. If it's something life challenging, something that can kill you or harm you in some way, that would be a 0.01. But primarily we're using 0.05. All right, so I have my statistic written right here. I'm not going to worry about rewriting it in there because I've already written it out, so I don't have a naked number. It's obvious to somebody where the number came from when I use it later in the problem. Okay, so for our plan, we had one sample. We saw it was a random sample of 500 kernels, so this is a one sample. Because this is a proportion, proportions are always z, and we're performing a significance test. So it's a z-test for, and we're trying to estimate the population proportion. So we have our procedure. Now we need to check our conditions. So we have random. Remember, we have to specify whether it's random selection or random assignment. So this is a random sample of 500 kernels. Okay, so we're good there. We want to check our 10%. We're sampling without replacement, so we gotta check it. So 500 is less than or equal to all popcorn in the store. Okay, so we're good there. And the last one is normal. For proportions, remember it's n times p and n times 1 minus p. So our n was 500. Our p, you got to go back to your hypothesis, is 0.4, which gives us 200. And then we have 500 times 1 minus p, which will be 0.6, which gives us 300, and both of those are greater than or equal to 10. So I want you to remember that you must use p if you have it. We're assuming the null is true, and if we're going to assume it's true, this is what we would expect to have happen. Okay, so that's why you've got to use that. If you have the p-value, the population proportion, you have to use it here. All right, so we've checked our conditions now. Now we need to find our z-score. So when we go over here to our do section, all right, we need to, we're going to draw our little curve here. It should be centered at 0.4. Okay, so we have, it's a normal with 0.4, and then standard deviation, we haven't calculated it yet, but it's going to be 0.022. We're curious about 0.36 and below. So this is what we're interested in. So when we find our z-score, you take our statistic minus our parameter and divide it by the standard deviation, which will be 0.4 times 0.6 divided by 500. This is where the 0.022 came from, is when I calculated that, and I got a z-score of negative 1.55. I was expecting the negative z-score because my boundary is below 4, so I knew it was going to be a negative. When I go look up at negative 1.55 on table A, I get a p-value of 0.0603. Okay. Now, we're going to make a conclusion, and so our conclusion, before we write that, I want to remind you what you need to include for your conclusion. So that's going to be our next AP tip. So the conclusion for a significance test must provide a linkage between the p-value and the alpha level You must also include context and a conclusion. And so we had a way that we did this. There was 3 components that we included when we were concluding our significance tests. The first that will help us get all of these is we're going to interpret the p-value. And when we were interpreting the p-value, what that looks like, that's the assume the null is true. In context. Okay, so you're making a statement, assuming the null is true, there's this probability of getting our statistic purely by chance. It's that statement. After we make that statement, we want to make a decision about the null. Okay. And that decision is you're going to compare the p-value to alpha and decide if you're going to reject or fail to reject. Okay, and you could write FTR for fail to reject. Okay, so we've assumed the null was true and what that means. Then we compare to our p-value and decide if we're rejecting or failing to reject. And the final thing, you have to include this too, is your conclusion about your alternative. So what does it mean? Your decision about your null, what does that mean for your alternative? Okay, so if we rejected, that means we have convincing evidence for the alternative. Okay, if we failed to reject, so I'm just going to put FTR, failed to reject, there's no convincing evidence for the alternative. If you include all 3 of those, you should not be losing any points for that, so you should be in a really good spot. So let's go back to our conclusion and see if we can make it include all of these things. All right, so here's the first component of interpreting the p-value. Assuming the proportion of caramel corn is 40%, that's our null, is true, there is a 0.0603 probability of getting p hat equals 3.66 or less. It's referring to this right here, purely by chance. Okay, so we interpreted the p-value. So now we need to make a decision about the null. And when you make your decision about the null, you're going to compare the p-value to the alpha and then decide reject or fail to reject. So here's our comparison. Because 0.0603 is greater than 0.05, we fail to reject the null. Now the last part says we need to make a conclusion about the alternative. We failed to reject, so that means we have no convincing evidence. So let's include this last part now. We do not have convincing evidence the proportion of caramel popcorn in the Chicago style at this store is less than 40%. Okay, we include all 3 of those things. We should get full points. Hopefully that was helpful. Let me know if you have any questions, and I will see you in class.